Hello friends, welcome to today's lecture analysis of Trusses. Myself Mr. Y.S. Patil, Department of Civil Engineering, Sharat Institute of Technology, College of Engineering, Yatra. In last lecture, we studied analysis of trusses by energy method or unit load method. In this lecture, we just solve one problem. This is the truss subjected to external loading. At A, it is hinge support. At D, it is a roller support. And two external loads, that is 15 kN at point B in horizontal direction and 40 kN at F in a vertical direction. First of all, we check the structure is determinant or indeterminate structure. So how to check that determinant or indeterminate structure? The determinant structure is that they satisfy the equation M is equal to 2J minus 3, where M is equal to number of members, J is equal to number of joints. So let us see in this structure number of members. Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So member of truss is 11 and number of joints is 1, 2, 3, 4, 5, 6. So J will be 6. So 2J minus 3 is equal to 2 into 6 minus 3 is equal to 9. So member is greater than that 2J minus 3. So 11 is greater than 9. So number of redundant force is equal to 9. This is the difference between 11 and 9 is the number of redundant forces. So first calculate reactions RAV, RAH and RDV. So by using that equilibrium condition, summation Fx is equal to 0. We know that for hinge support, number of reaction is 2, that is vertical and horizontal. So total number of horizontal force in the system is 2, that is 15 kN, and second one is a RAH. So RAH is equal to 15 kN, and that force going in opposite direction of this force, that is in the left side. Then next summation Fy is equal to 0, means upward force, that is RAV plus RDV is equal to downward force, that is 40 kN. Then summation M is equal to 0. Taking moment about A. With respect to A, 15, this is a force into perpendicular distance is 3, that is 15 into 3, direction of movement is clockwise. Then 40 into distance is 4, the direction of the movement for 40 with respect to A is clockwise. So 15 into 3 plus 40 into 4, plot on the left side. Then RDV into distance 4 and the direction of the movement is anti-clockwise, so plot another side. So RDV value will be 51.25 kN. So put up this RDV value in this equation and we got RAV value is equal to minus 11.25. What is the indication of the minus sign? Whatever the assumption we made previously, that assumption is wrong. Basically we are assuming that going in upward direction, but instead of that upward direction it will be going in a downward direction. So I want to first, this structure will be determinant, so I want to remove these two members for this structure will be determinant. So remove that BF and AC member. So number of redundant force is 2. So remove two forces, that BF force means this BF and this AC member will be removed. So now this structure will be determinant. So this structure now solved by method of joint. First consider joint A. Before solving this structure, assume all members in tension. All members in tension means whatever plot or marks all members in a arrowhead like this, means away from origin, and consider all members are in tension. Whenever your answer is positive, your assumption will be right. If answer is negative, your answer will be right but your assumption will be wrong. So let us see one by one. Consider joint A. Number of forces meet at joint A is 4, that is 2 reactions and 2 members. So member is FAD and FAB and reaction is 11.25 kN and 15 kN. So summation Fx is equal to 0. That Fx is equal to 0 means horizontal forces of all RGBs of the all horizontal forces should be equal to 0. So FAD is equal to 15 kN. Then summation Fy. Summation Fy is equal to 0 means algebraic sum of the all vertical forces should be equal to 0. So FAB is equal to 11.25. Then next consider joint D. At joint D, first summation Fx horizontal consider all horizontal forces in the system, one horizontal and one inclined forces. So split this inclined force into two perpendicular components, that is F cos theta and F sin theta. The F cos theta going in a left direction, so FAD plus FBD cos 36.86. FAD plus FBD cos 36.86. We know the value of the FAD is equal to 15, FBD cos 36.86. So FBD value will be minus 18.75 kilonewton. Then summation Fy is equal to 0. The number of vertical forces is 1, 2 and the y component of this FBD, that is FBD sin 36.86. So RDV plus FCD plus FBD sin 36.86. RDV value will be 51.25 plus FCD plus, that is FBD value will be minus 18.75 into sin 36.86 is equal to 0. So FCD will be minus 40 kilonewton. Once again I repeat that minus sign means whatever the assumption, we assume that FCD is a tension, but this is not a tension, this is a in compression. Then next consider joint B. Summation Fy is equal to 0. The number of forces in the y direction is 1, 2 and y component of this. So FB going in upward direction, FAB in a downward direction, and y component for this FBD is in downward direction. So FBE plus FAB plus FBD sin 36.86. So FBE is equal to FAB 11.25 minus 18.75 sin 36.86. So FBE value will be 0. Then summation Fx is equal to 0. So total number of forces in the horizontal direction is 1, 2 and x component of this FBD. So FBC plus FBD cos 36.86 plus 15. So we know the already the FBD value. Put up all the values in this equation, the FBC will be 0. Then next consider joint C. First consider summation Fx is equal to 0. Total number of horizontal forces is 2, that is FBC and x component of that FCE. FBC plus FCE cos 36.86 is equal to 0. So FCE will be 0. Then summation Fy is equal to 0. The algebraic sum of all vertical forces should be equal to 0. Total number of forces is FCD, FCF and FCE sin 36.86. So FCE and FCF going in upward direction and FCD going in a downward direction. And already we know the value of the FCE is 0. So FCF will be 40 kilonewton. Then consider joint E. Summation Fx is equal to 0. FE plus FCE cos 36.86. So FCE value will be 0. So FEF value also 0. Now remove all external forces, that is 15 kilonewton and 14 kilonewton, and apply unit load at redundant force, that is BF and AC. Means at from point B and from point F apply 1 kilonewton force, from point A and from point C apply 1 kilonewton force, and calculate K forces in each member. So first consider joint B. That is summation Fx is equal to 0. So KBC plus 1 cos 36.86. This value becomes 0 because there is no vertical force, only inclined force is there. So KBC value is equal to minus 0.80. Then summation Fy is equal to 0. That is KBE plus sin 36.86. So KBE value is equal to minus 0.60. Then next consider joint C. Summation Fx is equal to 0. So number of forces on the horizontal direction is KBC, KCE 36.86 and 1 sin 36.86. So KCE value become 0. Then summation Fy is equal to 0. KCF plus KCE sin 36.86 and 1 sin 36.86 downward direction. So KCF becomes 0.60. So put up all values, that P values, K values, L, means form a table, that is serial number, member, P, K, L. Area is a constant, so I remain blank as it is. Then PKL by A and then K square L upon A. So member AB, AD, BE, BC, BD, EC, EF, CF, CD, BF, AC. Put up all corresponding force values, that is P values, then K values and corresponding length for that particular member. Then calculate PKL upon area. Then next K square L upon A. So by calculating this, take summation of this PKL is 72 and that K square L upon A summation is 14.7. So find correcting factor X. How to find out correcting factor X is minus summation PKL by A divided by summation K square L by A. So correction factor X is minus 4.89. Now the final forces in the member of the redundant is equal to Sx is equal to F plus K into X. F means forces in the member, K is a K force or K factor and X is a correcting factor. So for example final force in AB is FAB, that is 11.25 plus 0 into minus 4.89. That answer will be 11.25. Similar manner we calculate all forces in the member, that is final forces, and that SAD is equal to 15 plus 0 into 4.89, that is 15. So calculate such a manner all forces. This is the procedure to solve indeterminate structure by energy method or unit load method. Thank you.